All right, so the last page, page 10, is going to put us in, in touch with a couple more of the more challenging type problems. Triangle ABC is isosceles with base AB. Okay, so make a little statement there. Isosceles, triangle ABC with base AB. It's a given. We know that ME is going to be perpendicular, a lot of perpendicularity, ME is congruent, all that good stuff. And we need to prove that M is the midpoint of AB, right? Somehow, some way. Right? But let's stop with the isosceles triangle business, right? What I can state immediately is angle CAB is congruent to angle CBA. And that's because base angles of an isosceles triangle are congruent. All right, so I'm going to just tuck that in right there. All right, so now let me address the perpendicularity part of it. ME, perpendicular to AC, and MF and CB, same deal. So given ME and AC, MF and BC. All right, so basically the ones that look like they're perpendicular, which often is the case. Almost always is the case. All right, little eyelash. All right, so it looks like we're kind of on our road to proving not anything about the whole triangle, but that those two little triangles, which I'll illustrate, or at least attempt to, here, these two guys, we're on the road to proving that these two are congruent. And if we can prove that they're congruent, then we'll be able to prove that all their corresponding sides and angles are congruent. All right, so they told us that ME and MF are congruent to one another. All right, so, but before we get to that, let me just make a statement here. And this is an important statement. I need to address the congruence of certain angles. I need to state that AEM, angle AEM, is congruent to angle BFM. And that's because perpendicular lines form right angles but those right angles are 90 degrees, and those 90 degrees are congruent. So perpendicular lines form congruent 90-degree angles. All right, we talked about that a few pages ago. That's a nice way of concisely getting all these ideas kind of merged together instead of making them separate statements. All right, so then they flat out tell us that ME and MF are congruent. So that's not, I was about to write a 4. ME congruent to MF. Given. So we got a couple more steps in here. One is going to be, well, I have two congruent angles, two sets of corresponding congruent angles, and a pair of corresponding congruent sides that are not contained within those angles. So another AAS. So triangle AEM congruent to triangle BFM. I have to be able to squeeze in 2 more little statements here. All right. So I now know that this side is going to be congruent to this one. AM congruent to BM. And that's CPCTC. And then finally we're at the proof statement. Because if I know that they're congruent, then M has to be the midpoint. So I'm at the proof statement, and all I'm going to write is the proof statement. M is, it looks like I'm saying Ms, the midpoint of AB. Abbreviations are encouraged. Definition of, I put a period after the wrong thing, midpoint. One of these days I'll learn to write small first and then write big later on once I realize I have a ton of room. But apparently that lesson is for another day. All right, last one, last and final. Maybe that lesson is for now. Triangle ABC is isosceles with A being congruent to B. Given. CD is the altitude. Of ABC. All right, still given. Now, altitude, that's an important piece. All right, so they flat out gave us one piece of information, very, very important piece of information. But the other one, I know, the A being congruent to B. But the second one is kind of more roundabout. All right, so we want to address that. Altitudes form right angles with the base. So what I'm going to state here is angle ADC. It's basically this proof's way of saying that CD is perpendicular to AB. So I'm going to make the statement, I'm going to try to do a combo statement here again. Angle ADC is congruent to angle BDC. Because if you're always beholden to just whatever the rules are, you say, oh, I got to say definition of this, definition of that, then you'll find yourself with like a 20-step proof. Whereas if you start logically combining some of them, then things go a little bit quicker and easier. All right, so let's play this out logically. We have an altitude which forms right angles, which are altitudes perpendicular, which forms right angles, and those right angles are congruent. So an altitude of a triangle is perpendicular to the base, forming congruent 90-degree angles. So I just chucked in a little bit of the altitude forming those perpendicular relationships, but then I just threw on what I would write if they just told me it was perpendicular to begin with. All right, so it kind of got the best of all worlds here. All right. Now, next conclusion, and this is the most important one. And it's also going to demonstrate that if you're ever in doubt, go with AAS, because it seems to be coming up pretty frequently. These two, and not just for these proofs, it comes up very, very frequently for lots and lots of proofs. I can state that AC is congruent to BC for a few reasons. But the most popular one, I mean, because it's in an isosceles triangle, two sides are congruent, but I could also state, and this works for triangles in general, in a triangle, sides opposite congruent angles are congruent. All right, so now I need to make a statement of congruence for the triangles themselves. So I can say that triangle ADC is at long last congruent to triangle BDC. And this is going to be because of the AAS axiom. Then I can go with my corresponding parts. Now, it does require you to know what a median is. So I can state now that AD is congruent to BD. And that's because of corresponding parts of congruent triangles are congruent. And now I can also state D is the midpoint of AB, definition of midpoint, and then the last step in the whole shibiggity bangity boom here is really relying on our knowledge of what a median is. So CD is the median of triangle ABC. A median intersects the midpoint of the base of a triangle. All right, so definition of median of a triangle. All right, so little Easter egg for this video. First person to message me with the most popular axiom to prove a triangle congruent will receive 1 bonus point. Again, this only applies to my own students. All right. And there it is.